Hello guys, in this video I am going to be showing you guys how to make copper carbonate. So first of all, I'm not going to show you any chemicals. I need to give a quick head start. So for copper carbonate, I'm going to need to mix a molar ratio. So like for every 1 mole of copper sulfate, I must add 2 moles of sodium bicarbonate. Unless you have sodium carbonate, then it will be 1 mole of copper sulfate to 1 mole of sodium carbonate. However, I'm using sodium bicarbonate, so I'll need to use 2 moles of sodium bicarbonate. After some calculations, I am going to be adding 72 grams of copper sulfate to 84 grams of sodium bicarbonate. Oh, hold up. Wait, that doesn't sound right. You see, I store my chemicals in milk cartons. This ain't copper sulfate. This is copper sulfate pentahydrate. You know, pure copper sulfate, the anhydrous one, would be white in color. But blue copper sulfate is not pure copper sulfate. It is copper sulfate that has been reacted with water to form copper sulfate pentahydrate. The chemical formula is here. Copper sulfate pentahydrate, 1 mole of it is equivalent to 250 grams. 1 mole of anhydrous copper sulfate is around 160 grams. So I will be mixing 125 grams of copper sulfate pentahydrate with 84 grams of sodium bicarbonate. Basically half a mole of copper sulfate pentahydrate with 1 mole of sodium bicarbonate. I did the calculations on this piece of paper. It's very messy. I won't show it to you because my handwriting is awful. So when that happens, it will release carbon dioxide gas, water, but I'll get copper carbonate in the end. It will also release sodium sulfate, but I'm throwing away the sodium sulfate because I don't need sodium sulfate. I just want the copper carbonate. So once I get the copper carbonate, I'll filter it out and then I'll dry it up. You'll get the rest. I'll show it to you. Just give me a moment. Alright, so skipping ahead. I didn't have to show you guys weighing my chemicals because, you know, it will take a bit of time. So I'll just skip a part. So right here, I have 125 grams of copper sulfate pentahydrate. 125 grams. And here is 88 grams of sodium bicarbonate. I'm supposed to use 84 grams, but the reason why I use 88 is because I'm just using a slight excess of sodium bicarbonate so that to make sure all of this blue crystals react. Theoretically, I should get 62 grams of copper carbonate because, you know, half a mole of copper sulfate reacting with 1 mole of sodium bicarbonate would give half a mole of copper carbonate, which should be 62 grams. I'm hoping to get around that. Any less, that's okay. So I just need to dissolve my copper sulfate in water, and I'll also need to dissolve my sodium bicarbonate in water. Just a quick note, when I mix the sodium bicarbonate with the copper sulfate, I gotta mix them slowly because the sodium bicarbonate would react to give a lot of effervescence of carbon dioxide gas, which can form an explosion. I wouldn't say explosion, more of like it will make a very, very white foamy mess that can take me a long time to clean up. So I'll just let it dissolve and I'll skip ahead once more. Alright, after hours and hours of mixing, I finally managed to dissolve all the constituent reactants into water. Copper sulfate, sodium bicarbonate, and sodium bicarbonate. You know, here's the funny part. Copper sulfate dissolved quite fast in water, but sodium bicarbonate, on the other hand, took literally ever. It was so difficult to dissolve in water. I thought, you know, all sodium salts are soluble in water, right? So sodium bicarbonate should not take very long to dissolve in water. But for some reason, it just didn't dissolve properly. I even heated it up. Well, you know, heating up sodium bicarbonate is not a good idea since it will decompose to form sodium carbonate. So I gave it very gentle heating. Anyways, after a lot of effort, I finally managed to dissolve sodium bicarbonate into a colorless solution. Would you look at that? A colorless solution. This took a lot of effort. Anyways, I got some super concentrated copper sulfate, and I'm going to add this really, really slowly to this sodium bicarbonate. Oh my goodness, I don't think I'm mentally prepared. Just give me a moment. Let me get mentally prepared. I think I'm more mentally prepared. What I did was I cleared the surroundings in case I mess up and it overflows. Okay, before I mix, just a quick recap. So what is gonna happen is the sodium bicarbonate will react with the copper sulfate to release carbon dioxide gas, water as byproducts, and the products that I want is copper carbonate. It will also release sodium sulfate, which is a throwaway. Okay, I'm gonna mix these really, really slowly. Oh yeah, by the way, the chemical equation's here. I forgot about chemical equation. Here. Okay, I'll mix it really slowly. Oh, surprisingly, there's not much effervescence. I think it's because I heated it up and then it thermally decomposed. But I don't trust myself completely to the point where I'm going to pour it fast, because I'm not going to pour it fast. Oh my goodness, okay. Although there's not much effervescence, there's definitely not zero. Something's not right. It's supposed to turn into a green color precipitate, but for some reason it's dark blue. Oh, I think I know why. What happened was I added a little bit of sodium hydroxide to dissolve some of the bicarbonate into carbonate, but I think I added too much hydroxide. Oh my goodness, this is so scary. It's like if I just add a little too much, it can overflow. It's definitely forming effervescence. It's not a lot, but it's definitely enough that if I mess up, then it'll become a big mess I'll have to clean up. This kind of reminds me of the time when I was adding hydrogen peroxide to sulfuric acid, and it was so scary. Because you know, if you add too much 30% hydrogen peroxide to sulfuric acid, if you add it too soon, then the solution can literally explode. Which is why I added it super slowly. But surprisingly, it can literally dissolve Mentos. And if you add sugar to piranha solution, the sugar will literally vaporize into carbon dioxide, which was pretty cool. But don't worry, I'm never doing that again. For safety reasons, of course. If you look closely, you can definitely see that there are very small bubbles forming. I'm not gonna add any more right now until the effervescence slows down, because every drop I add by this point risks overflowing. I'm very traumatized from my last videos, because one video I mixed sodium bisulfate with sodium bicarbonate and it exploded. Another video I mixed sodium bicarbonate with copper sulfate, except I added the sodium bicarbonate all at once and then it overflowed. So right now I'm adding it super slowly. You know what's interesting is that at the top you can see the green precipitate of copper carbonate, and at the bottom you can see copper hydroxide precipitate. But the copper hydroxide will quickly decompose into copper oxide. But that's fine, having a mix is okay as long as I filter everything. Wait, but this will affect my yield though. My yield should be 62 grams of copper carbonate. But if it contains a mixture of copper carbonate and copper hydroxide, it will be a bit inconsistent. This won't work very well. But that's okay. As long as I react it with excess, then it should be fine. I just added a little bit and now it's rising, like flour. I think I should change the camera angle. Just look. it's like bubbling with green foam. I don't know how to explain it. You just imagine it your own way. Okay. So there's like, the top layer is copper carbonate, the bottom layer is copper hydroxide, then the middle is, it's not copper sulfate, I guarantee that. Oh my goodness, it's rising. Okay, my anxiety is building up. Don't overflow, please. Don't overflow. Just look at the bubbles. These are big bubbles. I promise this is not a soapy solution. Okay, I'll let it speed up. You guys will experience it in seconds. I'll experience it in hours. Alright guys, so I've let my mixture settle for 12 hours. You may see that the volume of the mixture decreased. Well, that's because I've been decanting it and then filling it with distilled water, then decanting it again, so that I can try dilute the sodium sulfate as much as possible. That's because I don't want the copper carbonate and copper hydroxide to be contaminated with sodium sulfate, which is why I dilute it. Anyways, so I am going to move on to the hardest step, filtration. It's not difficult, it just requires a lot of patience, and it's something I clearly lack. Anyways, I'll need to fold it in half, then fold it into a quarter, and then I place a finger, okay, you see, right? It's a quarter fold. Now, I put my finger through like one side, and then I basically roll it open, and now it's dome shaped. Now I can begin filtering. Now let me just decant a little bit more of the solution first, because I don't want to just wait for the solution to filter. You can see that the solution is almost colorless. Well, I think I added a little too much copper sulfate. I thought I was adding the sodium bicarbonate in excess, but apparently not. Anyways, time to get filtering. So I'm hoping to get 62 grams of copper carbonate. If not, that's okay. I did my best after all. Oh wait, I'm clearly mistaken. You see the filtrate? It is completely colorless. Then that means that this isn't a solution, this is a mixture. A heterogeneous mixture. This is homogeneous. So, it's colorless. This might take me hours, but that's okay. My exams are over, so my life is easier. I don't like exams anyways. As you can see, the filtrate is colorless. That means that I've added sodium bicarbonate in excess. Maybe by like 2 or 3 grams, but that's worth it. That way I can guarantee that all my copper carbonate has been used, and that I can get 62 grams if I do my filtration perfectly. I don't know what to do with the copper hydroxide though, because I know that as soon as I filter it out and then I let the copper hydroxide dry, it will decompose into copper oxide, which will be a bit annoying. But here's the thing though, copper carbonate, copper hydroxide, I don't do molar calculations when I react it with acids. All I do is I just add a shit ton of the solids into the acid, and then I just let it react, and then until there's no more effervescence of carbon dioxide gas, and I see that there's still the copper carbonate residue in the acid, then I know that the reaction is done. I'm gonna get a lot of copper carbonate from this. Meanwhile, let me talk about today's sponsor. Oh wait, I don't have any sponsors, that's just sad. You know, since I got nothing to talk about and I don't want you guys watching this filtering all day. Look at it. Green, colorless. Anyways, I don't want you guys watching it the whole day because it's gonna be boring. So I will spare you guys the pain. Alright, so after like about 4 hours of just filtering and filtering and filtering, I managed to get my final dose of copper carbonate. Let me measure the grams. Hopefully I get 62. If I get any less, that's okay. Oh my goodness, 123 grams. I thought 62 grams of copper carbonate would be how much I get, but 122, damn. Oh wait, my bad. There's still water trapped inside. You know, if I measure the mass now, it won't be very accurate because you see there's still water trapped inside, so I might need to leave it for another 4 hours to let it dry. Then I can measure the mass. Give me a moment. Alright, so it's been approximately 2 hours and I've let my copper carbonate dry under sunlight. It's not completely dry, it's like almost fully dry, but like you get the idea. So I'm gonna weigh it. I suppose a little bit of water, I'll just subtract, I guess I'll subtract 8 grams. Okay, I'll minus 8 grams. That's my estimate. 63 grams, okay, so let's say minus 8. Then I'll have 55 grams of copper carbonate. 55, okay, 55 grams. So theoretically, I should get 62 grams of copper carbonate, but now I have 55 grams. So 55 divided by 62, 0.887, 88.7%. So my yield is 88.7%. I don't know how I lost my 11.3% of copper carbonate. I suppose it may have got clogged in the filter pores. So during filtration, a bit of copper carbonate may have got clogged in the pores and then I cannot get it out, but that's okay. Anyways, I've put some copper carbonate into this beaker here. You can see it's still a little bit wet, but that's okay. You see that copper carbonate is insoluble in water, so whatever happens, it won't dissolve. I'll just add the copper carbonate and maybe like 1 more spoon. I'll add 1 spoon, wait. Okay, I think this is enough. Now with that 1 spoon of copper carbonate, I am going to add some sulfuric acid. You're gonna see what happens when you add sulfuric acid to copper carbonate. There's effervescence of carbon dioxide gas. Let me just mix it. Okay. Now after adding the sulfuric acid, the green solid has now dissolved into a blue solution. You want to know what that blue solution is? It's obviously copper sulfate. You know, copper carbonate, what's funny is that I extracted my copper carbonate by mixing copper sulfate with sodium bicarbonate to get copper carbonate, sodium sulfate, water, and carbon dioxide. Now with the copper carbonate, I just add sulfuric acid and I got this copper sulfate all over again. It's pretty cool. Alright, now I guess y'all know how to make copper carbonate on your own at home. So just remember, you need to do a lot of molar calculations for this. It's a price that has been paid off. Alright, thanks for watching. I'll see you guys again maybe next week.